ahead and go through 4.de.5, okay? All right. So, we're started off, we're given this phase map. We have our diagram over here. We have some sodium and potassium mixture going in, 100 kilograms per minute. We have 20 weight percent, correct? And we're adding back some pure potassium so that basically we can get over here, right? We're adding some pure amount to our 20% to try and get into this region because we want to get out pure potassium. So we have to be on this side. So this is our new way to try and do it. We're going to see if it works. Okay, so first off, we're asked to figure out what is the composition in stream 3, right? So what did you guys do first to figure out the composition in stream 3? What do you need to know the composition of in this system? So we want to find the composition of stream 3. What I did is I found the composition of stream 2. Does that sound viable? All right. So I have the composition of stream 2. I found that was going to be 10%. That makes sense. So I'm adding two things. One's 0%, one's 20%, 10%. It's in the middle. Cool. All right. So I know that I'm here at 1%. And then I'm doing a solid liquid separation at 0 degrees Celsius, right? So I can go ahead and draw a line there, bring my fulcrum. I know that my pure K is coming out of 4, so that's on this side, and my stream 3 is over here. Okay, so I went ahead and I found my composition of stream 3 to be 0.165. Does that sound good? Okay. All right, so now in part B, we're told that this process won't work. Why? So I started by looking at the flow rate of stream 4, okay? So this flow rate of stream 4. So I said to myself, let's do a lever rule. That seems pretty simple. I have this here, so I can get the total. I have this one, and I went ahead and calculated that my stream 4 was 121 kilograms per minute. So I have that. So how does that look? No. Why not? What did I do wrong? Yeah, Dorothy.
Oh, right.
So yeah, I used the lever rule wrong, right? So I used the wrong lever arm when I was calculating my stuff. So what I should be doing is taking this 0.615 and comparing it to this lever to get my stream 4, okay? So I should have 121 being my flow rate of stream 3 and 79 being my flow rate of stream 4. Okay. So if my flow rate of stream 4 is 79, then I can't be giving out 100 kilograms per minute to go into stream 6. Does that make sense? You guys were given that. This is not there. It's not going to happen. I don't have anything here, okay? So this, as it is not going to work. Okay. So did anyone approach this in a different way? I'm going to go through real quick. You could also do a mass balance on K around the whole system, right? It's another way to look at it. Basically, you know how much K is coming in. You know that you have pure K coming out and 83.5 weight percent K coming out in stream 3 because we have that composition. What else do I know about any of these streams? Do I have a flow rate of stream 5? Do I have the flow rate of stream 3? Yeah. I just calculated the flow rate of stream 3, right? Using my lever rule. So I can say that based on this overall flow rate of 121 kilograms per minute coming out of stream 3, that means I must have 101 kilograms per minute of K coming out of stream 3. Well, that's more than the 80 K that I'm putting into the system, so that's not going to work. Okay, cool. So for the next part of this, we were asked to see if we could make this process work ever. So the first thing I wanted to try is to increase the flow rate of F4, right? Because if I have more F4, then I could get some of it out in 5 and then put some of it in 6. So basically, I'm going to bring this down here, extend my line, and now my lever arm for this side is longer. Okay? So I went ahead and did that lever rule. But the most I could really seem to get was still 82 kilograms per minute. So that's not going to work. So that means I can't increase my flow rate of F4 by changing the temperature of my solid liquid separator. What's another thing that I could try? What else could I try and change about maybe stream 2 going into the system? Anything? I thought maybe I could like make it less, right? So I could, if I change this flow rate, maybe I take some of it. So like I know that I can get 82 coming out in 4. So what if I only take like 40 and put it in stream 6 and then get the rest out as pure K? Like that seems fine. Okay? So if I decrease if I decrease some F6, then the concentration of F2 gets closer and closer in this direction. So you can see my output here gets even smaller. And if I do it the other way, F6, it dilutes my F2 stream. So either way I do it though, I'm going to lose some of my K to F3, right? I know that somehow going out to that F3 based on where this region is falling. So it'll always, F4 is always going to be less than the F6 that I'm putting in. So did you guys get that when you were doing this? Does that make sense to everyone? Yeah? Kind of, maybe? Yeah. All right. So this process cannot be made to work. It's not going to be working anytime soon. Don't don't put a lot of money into this kid. Probably not a good idea. All right? And then I have a thing just kind of showing that you can go through the math and you'll be able to find that F6 is always greater than F4 by the lever rule and knowing that the composition is about 0.19 between these two regions here. So if you want to look at that, let me know. We can go over that as well. Okay? Any other questions? All right, good job.